Imagine it is 3 a.m. and your production server is hemorrhaging memory. You trace the leak back to a logic block committed yesterday. It looks clean, but it was generated by an AI tool that didn't realize your project migrated to Node JS22's native fetch and instead suggested an outdated, unoptimized polyfill pattern that conflicts with your custom middleware. This is the AI coding trap. Many developers treat tools like Cursor or GitHub Copilot as magic wands, but without deep project context, these tools often hallucinate patterns that worked in 2023, but are anti-patterns in 2026. In high-stakes environments, simply being fast at writing code is useless if that code lacks the architectural awareness of your specific legacy constraints or security protocols. We are seeing a surge in blind commits where developers trust the LLM more than their own linting rules. But senior engineers who survive this era aren't just faster, they are more critical. They know that an AI without a human architect is just a high-speed bug generator. By the end of this lecture, you'll learn how to stop being a passive consumer of suggestions and start acting as a systems pilot who directs these models with precision. This shift in mindset is what separates the replaceable coders from the indispensable engineers who will thrive in the next decade. This is not just a theory. I will show you the exact framework for AI-driven system orchestration that prevents these production nightmares from happening in the first place. In the professional field, we are moving beyond autocomplete and into the era of autonomous agents. If you are still using AI just to finish your sentences, you are already falling behind. The ROI of 26 coding tools isn't measured by lines of code per minute, but by the reduction of cognitive load and the automation of entire workflows, from refactoring a monolith into microservices to generating comprehensive integration tests for a complex API. Tools like Claude Code and Cursor's Composer mode are no longer just suggestions. They are junior partners that can execute terminal commands, read your local documentation, and even fix broken builds autonomously. But here is the catch: an agent is only as good as its supervisor. You need to move from a writer role to an editor and orchestrator role. This lecture is your roadmap for that transition. I promise that by the time we finish, you will know exactly how to leverage agentic workflows to handle the grunt work so you can focus on high-level system design and business logic. We aren't just talking about saving time, we are talking about increasing your technical impact by 10x while reducing the mental fatigue that leads to burnout. But wait, is everyone actually happy with these tools? The latest data suggests a massive divide in developer satisfaction that we must address immediately. Let's look at the hard numbers from the JetBrains 2020-26 Developer Ecosystem Survey, which surveyed over 10,000 professionals. GitHub Copilot remains the market leader with a 45% adoption rate due to its deep integration with the enterprise ecosystem. However, the real story is the explosive growth of Claude Code and Cursor. Claude Code, Anthropic's CLI-based agent, saw an 18% surge in adoption within just 6 months. Why? Because developers are discovering that for complex, multi-file refactoring, the Sonnet 3.7 and 4.0 models provide a level of reasoning that Copilot's standard autocomplete simply can't match. We are seeing a trend where teams keep their Copilot subscription for basic tasks, but personally pay for Cursor or Claude Code to handle the heavy lifting. The data shows a clear shift. Developers are prioritizing reasoning capability and large context windows over simple ID integration. If your tool doesn't understand your entire codebase through RAG or advanced indexing, it's becoming a liability rather than an asset. This survey highlights that we are in a multi-tool era where the best engineers pick their AI weapon based on the specific architectural challenge at hand. But high adoption doesn't always equal high satisfaction. In fact, there is a hidden frustration gap in the data that reveals exactly why so many developers are currently looking for alternatives to their current setup. Why are developers frustrated despite having world-class AI at their fingertips? The survey reveals a satisfaction gap rooted in 3 main areas: hallucination fatigue, privacy concerns, and the context wall. Many developers feel like they spend more time correcting AI mistakes than writing original code. This happens because most tools still struggle with system-level context. They know how to write a function, but they don't know how that function interacts with your specific Kubernetes config or your localized database constraints. There is also a growing subscription fatigue. Developers are tired of paying $20 a month for 3 different tools just to get one decent refactor. The mind map of 2026 developer sentiment shows that the new demands are shifting toward local LM support for privacy and tools that can truly see the entire repository structure. If you feel like your AI tool is just a glorified copy-paste engine, you aren't alone. But there is a way out of this frustration. The engineers who are actually happy are the ones who have built a decision framework for tool selection, knowing exactly when to use Claude for logic and when to use Copilot for boilerplate. This level of strategic tool usage is what we are going to master next. Does this frustration mean we should go back to manual coding? Absolutely not. It means we need to choose our tools more scientifically, and in the next chapter, we will put Big 3 into a head-to-head battle to find the winner. In the field, we often encounter a phenomenon I call context amnesia. You're working on a complex refactoring task involving 5 different services, and suddenly your AI assistant starts hallucinating variable names that don't exist. This happens when the context window is too narrow or poorly managed. GitHub Copilot, while a pioneer, traditionally relied on a sliding window that prioritizes local file proximity. In contrast, 2026 iteration of Cursor uses an index everything approach, creating a vector embedding of your entire codebase. This means when you ask to update the user authentication flow, it actually remembers the middleware you wrote 3 months ago in a different directory. The Titan Duel here isn't just about who has more tokens, it's about effective context retrieval. If the tool can't maintain the mental model of your architecture, it's just a fancy autocomplete. Experienced engineers look for tools that can handle 100 kilobytes of active context without degrading performance during long-form architectural changes. Question, but is a bigger window always better? Next, let's see how these tools actually sit inside your IDE and affect your daily workflow. Developers are notoriously religious about their IDEs. If you've spent years perfecting your JetBrains shortcuts or your VS Code extensions, switching tools feels like moving to a new country. Copilot has the ultimate home field advantage in VS Code, offering a seamless ghost text experience that feels like a natural extension of your brain. However, for those of us in the JetBrains ecosystem IntelliJ WebStorm, PyCharm the integration has historically felt like a second-class citizen. Cursor took a radical path by forking VS Code itself, creating an AI-native IDE. This presents a massive dilemma for senior engineers. Do you abandon your highly customized JetBrains environment for the superior AI capabilities of Cursor? In practice, we see teams split down the middle. Those working on massive Java or Kotlin monoliths often stick to JetBrains AI Assistant because it understands the deep AST, abstract syntax tree, better than a generic external agent. Choosing a tool is no longer just about the LLM, it's about the friction between the AI and your existing development habits. Payoff, yet even the most integrated IDE feels limited once you realize what an autonomous agent can do in the terminal. Let's look at the newest heavyweight, Claude Code. This isn't just a chat box, it's a CLI-based agent with terminal control. While Cursor has its composer mode to edit multiple files, Claude Code can actually run your tests, read the error logs, and iterate on a fix until the build passes all without you touching the keyboard. It represents a shift from AI as Copilot to AI as an agent. In a real-world scenario, you might say, fix all the deprecation warnings in the legacy module and verify with npm test. Claude Code will grep the files, apply the fixes, and run the test suite. If a test fails, it analyzes the output and tries again. This level of autonomy is terrifyingly efficient, but it requires a high degree of trust. I've seen hours of manual find and fix work compressed into a 30-second execution loop. The battle between Cursor's GUI-based multi-edit and Claude's CLI-based agentic behavior is the current frontier of developer productivity. Teaser, but all this power comes with a price tag, and not just the one you see on the billing page. Let's talk about the AI tax. Subscription fatigue is real, but in an enterprise setting, the cost isn't just the $20 monthly fee, it's the risk of unpredictable usage. GitHub Copilot is the safe corporate choice with predictable flat-rate pricing and robust legal indemnification. Cursor and Claude Code often involve more complex tiering or per-token costs. I once saw a team blow their entire experimental AI budget in a week because an autonomous agent got stuck in a recursive loop while indexing a massive repository with millions of lines of generated code. When you're managing a team of 50 developers, that small difference in pricing models becomes a massive operational line item. You must evaluate the return on investment. Is the 20% increase in coding speed worth a 3x increase in tool costs? Most senior leads now use a hybrid model standardizing on one tool while allowing power users to bring their own key for specialized agents. Question, is paying the most expensive model always worth it? The answer lies in how easily you can swap them out when a better one arrives. Relying on a single LLM provider is a dangerous game. We call this model lock-in. If OpenAI releases a lazy update that degrades code quality, or if Claude's safety filters start blocking your legitimate security testing scripts, your entire workflow grinds to a halt. This is why bring your own key, and model flexibility are non-negotiable for senior engineers. Cursor excels here, allowing you to toggle between GPT-4, Claude 3.5 Sonnet, or even your own local Llama 3 instance via Ollama. In the field, we use specific models for specific tasks. One model might be a genius at CSS layout but struggle with Rust ownership rules. A flexible tool acts as a model router, letting you pick the right tool for the specific architectural challenge of the day. If your AI tool doesn't let you swap the brain while keeping your body, the UI, and context, you're not an engineer, you're a tenant of a single vendor's ecosystem. Payoff to solve this, the industry is moving toward a standard that connects any tool to any data. The most significant advancement in 2026 is the Model Context Protocol, or MCP. Think of MCP as the USB-C for AI tools. Previously, every AI tool had to build its own custom integration for Jira, GitHub, or your local database. With MCP, any agent, be it Claude Code or a custom internal script, can connect to a standardized server that provides context. This bridges the gap between a chat window and a context-aware engineer. Imagine your AI agent being able to query your Postgres production logs to diagnose a bug it just found in your React code, all because both systems speak MCP. This extensibility is how we move beyond the Titan Duel and toward an open ecosystem where the best tool for the job can access the data it needs. The winner of the 2026 landscape isn't just the smartest model, but the one that integrates most seamlessly into this protocol-driven world. Teasers are speaking of context. All these global tools face a unique challenge when they land in Korea, from network latency to linguistic nuances in local documentation, which we will tackle in the next chapter. In the Korean development landscape, Spring Boot is the undisputed king, but the real challenge often lies in the massive MyBatis legacy codebase found in SI and enterprise environments. While most AI tools are trained on modern JPA and Hibernate patterns, they frequently struggle with the complex, multi-thousand-line XML files common in local projects. I've seen many juniors try to use Copilot to generate dynamic SQL only to have it hallucinate tags that don't exist in older MyBatis versions. Claude Code, however, shows a surprising depth in understanding these legacy structures because it can ingest larger context windows of your specific mapper files. You must be careful because AI often suggests Java 17 or 21 features when many local systems are still strictly locked into Java 8 or 11. If you don't explicitly tell the AI your version constraints, you're looking at a build failure the moment you push to the dev server. But even if the code structure is right, what happens when the language itself becomes a barrier? Let's talk about the Hangul problem. In many Korean codebases, especially in public sectors or older finance systems, you'll find variable names or comments written in Korean or even Romanized Korean. This creates a massive multi-byte headache for some AI models. In my testing, Cursor and Claude 3.5 Sonnet handle Korean tokens with much higher fidelity than older GPT-based tools. When you ask an AI to refactor a method where the business logic is explained in Korean comments, a tool with poor tokenization will literally break the logic because it fails to grasp the nuance of the comment. For example, a comment saying "이 부분은 무시하세요, ignore this part," might be interpreted as code to be implemented if the AI isn't sharp enough. This leads to subtle bugs that are incredibly hard to track down during code reviews. This raises a critical question: can these tools handle the even more complex jargon found in specific industries? Domain knowledge is where most developers get burned. I once saw a project where an AI tool was asked to implement a tax calculation logic for a local fintech app. The AI provided a perfect English-centric implementation that completely ignored the specific progressive tax brackets and local regulations required by the National Tax Service. In the Korean banking and finance sector, the terminology is extremely specific. Terms like 가상계좌 or 실명인증 carry legal weights standard global AI models don't fully realize. If you rely on AI to generate these core business rules, you are essentially gambling with your compliance. Experienced engineers know that AI should be used for the scaffolding of the code, but the domain logics must be strictly audited by a human who understands the local legal context. This approach is what separates a senior engineer from a copy-paste developer. This gap between global AI capability and local requirements doesn't just stop at code, it extends to our documentation too. In the field, you'll often be handed a specification in an HTTP file or a heavily formatted Word document. Most modern AI tools, especially CLI-based ones like Claude Code, prefer Markdown or plain text. This creates a friction point. If you just copy-paste from a PDF or HWP into the AI prompt, the formatting often breaks, leading the AI to misunderstand the requirements. The best practice I've found is to use a Markdown-first approach. Convert your local Korean documentation into structured Markdown before feeding it to the AI. This ensures that the hierarchy of requirements, like what is a must-have versus a should-have, stays intact. Without this step, you'll find the AI consistently prioritizing the wrong features or missing edge cases hidden in those nested bullet points. Now that we understand these local challenges, how do we actually decide which tool to use for our specific team environment? Choosing the right tool isn't about which one is best in a vacuum. It's about your project's architecture and your team's size. For a solo developer or a startup working on a fresh greenfield project, Cursor is often the winner because of its deep AD integration and ease of use. However, if you are in a large-scale SI project with strict security policies where you can't easily switch IDs, GitHub Copilot remains the most politically safe and integrated choice within the JetBrains or VS Code ecosystems. For those of you doing heavy-duty refactoring or migrating legacy systems tasks that require looking at 50 files at once, Claude Code is currently unrivaled. You need a clear selection logic based on your technical debt level. If your debt is high, you need the analytical power of Claude. If you're just writing boilerplate, Copilot is enough. But is it really an either-or situation, or can we have the best of both worlds? The most efficient power users I know don't just pick one tool. They use a hybrid approach. Think of GitHub Copilot as your autocomplete for the mundane lines of code you write every minute. It's fast and unobtrusive. Then, bring in Claude Code when you need to perform architectural surgery like moving from monolithic service to a microservice or implementing a complex design pattern across multiple modules. In this setup, you use Copilot for tactical coding and Claude for strategic engineering. This prevents AI fatigue where you spend more time prompting than coding. You also need a checklist to ensure your team is using these tools safely without leaking proprietary local business logic. In the next chapter, we're going to get our hands dirty. We'll set up Claude Code from scratch and see how it performs in a real-world battle scenario, ready to move beyond the theory and start implementing. In the real world, the biggest problem with AI tools isn't a lack of intelligence, it's a lack of context. You've probably seen Claude or Copilot suggest a library that doesn't exist or use an outdated API because its training data is old. This is where Claude MD becomes your project's constitution. In 2026, we don't just rely on the model's memory. We explicitly define the project's rules, naming conventions, and architectural constraints in a machine-readable Markdown file. This file tells the agent we use PNPM, not NPM, and our internal API follows the result pattern, not throwing errors. Without this, the agent is just a smart stranger in your house. With it, it becomes an engineer who has read your entire internal wiki. I've seen senior developers waste hours correcting the same AI mistakes that could have been fixed in 5 lines of Markdown. But even with a perfect configuration, the AI still needs a way to actually touch your code. This brings us to how we actually execute these commands in a controlled loop. Now let's talk about agentic tasks. Standard chat interfaces just give you code and wait for you to copy-paste it. That is 2023 era workflow. In 2026, using the Claude Code CLI, the AI becomes an active participant in your terminal. When you tell it to refactor the authentication logic to use JetBrains instead of sessions, it doesn't just talk. It initiates a loop, it reads the file, proposes a plan, executes the change using real shell commands, and then critically runs the tests to see if it broke anything. If a test fails, it reads the error and tries to fix it automatically. This plan act verify cycle is what separates a senior's workflow from a junior's. You're not just getting code, you're getting a completed task that has already passed its first round of QA. But this power comes with a risk. If you give an AI terminal access without constraints, it might try to delete your entire database. Is the terminal really the limit of what these agents can reach? Actually, it goes much deeper than that through some called MCP. In the 2026 ecosystem, the Model Context Protocol, or MCP, is the game changer. It's the standard that allows Claude Code to talk to external tools like Jira, Confluence, or your local Postgres database. Think of it as a standardized plugin system for LLMs. Instead of you manually pasting error logs from a database, the AI can query the database itself to see why a query is slow. It can read your Jira tickets to understand the business requirements before writing a single line of code. This moves the AI from being a code generator to a systems engineer. When you integrate MCP, you are building a custom brain for your project that has access to all your internal documentation and data sources. This solves the silo problem where the AI knows the code but doesn't know the business context. But while Claude is pushing the boundaries of agentic behavior, GitHub Copilot has been building a massive ecosystem of its own. Let's see how the industry giant is fighting back with its extension model. GitHub Copilot is no longer just a ghost in the editor. By 2026, it has matured into a platform with a rich extension ecosystem. This is critical for enterprise environments where security and custom tooling are non-negotiable. Extensions allow you to plug in tools like Sentry for real-time error analysis within the chat, or Azure for instant infrastructure deployment scripts. The real value here is enterprise search. Copilot can now index your organization's entire private codebase, making it possible to ask questions like, how do we handle multi-tenancy in our other microservices, and get a response based on internal best practices, not just public GitHub data. This eliminates the not invented here syndrome where developers reinvent solutions because they didn't know a helper function already existed in a different repo. However, even with these extensions, the biggest failure point is still how we prompt the tool. Most people use generic questions, which leads to generic, buggy code. Let's look at how we can enforce team standards using custom agents and / commands. If you want Copilot to act like a senior engineer on your specific team, you need to use / commands and custom agents. In many organizations, we have legacy debt that isn't documented anywhere. By creating custom / commands like fix legacy or apply security headers, you are essentially pre-programming the AI with your team's specific knowledge and safety checks. For example, you can configure an agent to always check for SQL injection patterns unique to your proprietary ORM. Instead of repeating instructions every time, you encapsulate them. This is how you scale senior-level code quality across a team of juniors. I've seen teams build architecture agents that reject any AI-generated code that doesn't follow their specific folder structure. This keeps the codebase clean even when moving at AI speed. But here's the catch, even with the best setup, there are anti-patterns that can ruin your production environment if you're not careful. We'll dive into those production gotchas in the next chapter because what works in your local terminal might crash your servers at 3 a.m. In the real world, AI agents are double-edged swords. The biggest disaster I see in production environments isn't the AI failing to code, but the developer failing to secure it. The most critical mistake is PI leakage via prompt. Developers often paste raw logs or production database schemas into Claude or Cursor to debug a query, inadvertently sending sensitive data to third-party servers. Then there is the hallucinated dependency trap. I have seen instances where an AI suggests a library name that doesn't actually exist. If a developer isn't careful, they might accidentally install a TPA-squatted malicious package that sounds similar. Finally, there's the silent logic failure. The code looks perfectly clean and follows all linting rules, but it fails on obscure edge cases like leap years or specific time zone offsets that the AI wasn't trained to prioritize. These aren't just minor bugs. They are potential service outages waiting to happen. But wait, security is only half the battle. What happens when you lose the ability to actually read and understand the code you are supposedly writing? In 2026, the industry has clearly split between AI-assisted and AI-blind development. Experienced engineers use AI as a high-speed research assistant and boilerplate generator, but they remain the pilot in command. They verify every single loop and every async call. However, we are seeing a rise in AI-blind development, where developers treat the tool as an infallible oracle. They accept massive 100-line diffs without reading them, leading to technical debt at warp speed. This results in a codebase that functions today but becomes a legacy nightmare tomorrow because no human on the team understands the underlying architecture. I once saw a team deploy an AI-generated microservice that worked in staging, but it collapsed under high concurrency because the AI used a non-thread safe pattern that looked efficient on the surface. Distinguishing between helpful assistance and total reliance is the most important skill for a senior engineer today. This leads us to a critical question: how do we actually govern this mess before it breaks the system? To manage the risks of AI, we need a mandatory review process for AI-generated pull requests. We don't just approve anymore, we audit. First, every PR should explicitly tag which sections were written by an AI agent like Claude Code. This changes the reviewer's mindset from checking for typos to checking for structural logic. Second, no test, no merge is an absolute rule. If the AI can write the code, it must also generate the unit tests, which the human developer must then execute and verify for coverage. Third, we perform a version sanity check. AI often hallucinates deprecated API signatures. Verify that the suggested methods are still valid for your specific framework version. Finally, the most important part, the why test. If a developer cannot explain the specific reason why the AI chose a certain algorithm or data structure, the PR is rejected immediately. This ensures the human remains the master of the codebase. This isn't about slowing down, it's about moving fast without breaking things in production. Now that we've armored up against these production traps, it is time to look ahead at how the entire landscape will shift as we head into late 2026. We've covered a lot of ground, from the JetBrains survey insights to the raw power of Claude Code and Cursor. In 2026, the AI tool trap isn't about picking the wrong software, it's about stagnation and tool lock. Real-world data shows that high-performing teams are no longer loyal to a single ecosystem. They are building hybrid workflows where JetBrains handles the deep refactoring and static analysis, while Claude Code manages the agentic CLI tasks and cross-file feature implementation. You must stop thinking of these as fancy autocompletes. They are reasoning engines that require clear context and strict architectural boundaries. If you don't define your guardrails, as we discussed in the production gotchas, the AI will inevitably drift into technical debt. The roadmap isn't just about learning new keyboard shortcuts. It's about evolving into an orchestrator who knows exactly when to use a low LLM for privacy and when to trigger a massive reasoning model for complex debugging. This strategic flexibility ensures you aren't replaced by AI, but rather augmented by it. But is just knowing this strategy enough to change your daily output? Let's look at the concrete 7-day plan to actually pivot your workflow and start seeing results immediately. To wrap this up, let's talk about your immediate action items. You need a transition plan to move away from lazy prompting and into context engineering. On day 1, perform a context audit. Identify which parts of your codebase the AI struggles with most and why. By day 3, you should be integrating the Model Context Protocol, or MCP, to bridge your local documentation and database schemas with Claude or Cursor. This is where most developers fail. They expect the AI to just know the legacy debt without guidance. On day 5, switch to a CLI-first approach for at least one major feature using Claude Code to feel the difference in agency compared to standard chat. Finally, by day 7, establish your team's AI pair programming protocol, a set of rules on when to trust AI-generated unit tests versus manual verification. In the field, I have seen that the developers who thrive are those who treat their AI setup like their configuration files, constantly refined and highly personalized. The 2026 landscape demands that you are both a coder and a systems architect for your own productivity. This concludes our journey through the AI tool landscape. Keep your context clean, your prompt specific, and always verify the logic before it hits the main branch.